Welcome back. We've multiplied a whole number times a fraction and a fraction times a fraction. Let's revisit now these problems from the first video. How do you know when your answer should be expressed as a mixed number? Write each fraction as a mixed number when appropriate. For most of these answers, they are improper fractions. We talked about what improper fractions are last week. It's when you have the numerator equal or greater than the denominator. Here I have 9 is greater than 4, and so I can write that as a mixed number. 4 divides into 9 2 times because 2 times 4 is 8. Now I have to subtract to find my fractional remainder. 9 take away 8 is 1, so my answer is 2 1/4. Please notice that the denominator remains the same because that's how many pieces you have in one whole. Here I have the improper fraction 6/5. 6 is greater than 5, so I can write that as a mixed number. 5 divides into 6 one time, and 1 times 5 is 5. I have a fractional remainder by subtracting. 6 take away 5 is 1, and the denominator remains the same. We're talking about fifths, so that is 1 1/5. Here I have 4 is greater than 2, however, it's not a mixed number because 2 divides evenly into 4 2 times. 2 times 2 is 4. So the answer is 2. 4 divided by 2 is 2. Let's look at this next one. Here I have 10/3. 10 is greater than 3. I can write that as a mixed number. 3 divides into 10 3 times because 3 times 3 is 9. Let's subtract to find our fraction remainder. 10 take away 9 is 1, so that's 3 1/3. Here I have 5/6. 5 is not greater than 6, therefore that's the answer. It is called a proper fraction, and I can't write a mixed number for proper fractions. Last example, I have 18/10. 18 is greater than 10, so I can write a mixed number for this one. 10 divides into 18 one time. 1 times 10 is 10. When I subtract to get my fractional remainder, 18 take away 10 is 8/10. So 1 8/10 is the mixed number. That one is not simplified. How do you know a fraction can be simplified? Identify the fractions that are not simplified. Well, there's a handy little trick that you can use by looking at the numerators and denominators of the fractions you're multiplying to see if they share common factors. Now that's a tricky way of saying look at the top numbers and the bottom numbers and see are they the same or do they share common factors. With this black example here, I have a 3 on top and on the bottom. That means 3/12 is not simplified. With this next one, when I look at the numbers on top and on the bottom, they do not share common factors. That means that 9/40 is simplified. When I look at the red example and compare the top number to the bottom number, they do not share common factors. So 5/12 is simplified. When I look at my purple example and compare the top numbers to the bottom numbers, there are no common factors. And so 4/9 is simplified. Now be careful with this rule. You might say, well, there's 2 2s on the top. It doesn't matter. Or 2 3s on the bottom. It doesn't matter. They don't share common factors in both the numerator and denominator, and therefore 4/9 is simplified. When I look at this green example, it's harder to see. I know that 3 divides evenly into 6. They share common factors. They share a factor of 3. Therefore, 15/42 is not simplified. This next example is really hard for some kids to see. Here I have 4 and 10 share a common factor of 2. They're both even numbers. And 3 divides evenly into 9 because 3 times 3 is 9. So 12/90ths is not simplified. Let's look more closely at these 3 examples of fractions that are not simplified. And then you're going to answer the last question on your check for today. Simplify each of the fractions below. So looking at the first one that I have right here, 1/3 times 3/4, your teacher has taught you how to simplify fractions with the GCF, and you can do it that way. Or you can use prime factorization. There's a chart that's attached to today's assignment. I'm going to use prime factorization because it's something that you'll do in 7th grade, 8th grade, 9th grade, 10th grade, and so on. It's a common way of showing where the GCF comes from, actually. 3 is prime, so I just write it. And 12, if I make a factor tree for that number, 12 is 4 times 3, but 4 isn't prime. That's 2 times 2. 3 is, so the prime factorization for 12 is 2 times 2 times 3. Now, here's where it gets cool. 3 is on top and on the bottom. They are common factors, and 3 divided by 3 is 1. So the simplified fraction is 1 over 2 times 2 is left over, which is 4. So that's my answer. It's just that easy. Let's try it again. 15 over 42. The prime factorization for 15 is 3 times 5, and maybe offhand I don't know 42, but I can make a tree diagram to find it. 6 times 7 is 42. Now 6, I know that that's 2 times 3, and 7 is prime. So I have 2 times 3 times 7. Now look for common factors. They destroy each other. 3 on top and on the bottom destroy because 3 divided by 3 is 1. That leaves me with 5 over 2 times 7 is 14, and that's my answer. 5/14 is simplified. One more example. This is fun stuff. Now we already did the prime factorization of 12 with my black example, so I'm just going to copy it. 2 times 2 times 3. And 90, if I make a tree diagram for that, I know that 90 is 9 times 10. 9 is 3 times 3, and 10 is 2 times 5. And I just want to show you how the order I write the primes in does not matter with answers. Pair common primes. 2 divided by 2 cancel because 2 divided by 2 is 1, and it works for the 3's as well. 3 divided by 3 is 1. Now I don't have any other common factors, so it's simplified. Put it back together. 2 is on the top, and 3 times 5 is 15 on the bottom, and that's your answer. 2/15. So cool. Please answer the last question on today's lesson below, and you are done. Way to go.